Hey everyone, thanks for joining us today. Got a pretty interesting topic to share with you, which is AI security. Thanks for joining us, and thanks for Sergi for being here.
Yeah, happy to be here.
Yeah, well, you know, AI is like I used to say, tech was like drinking from a fire hose, but if you add AI, it's like, I don't know, 10
Yeah,
fire hoses in a fire truck. So let's get
just don't,
started.
yeah, don't try to keep up with it.
Yeah, let's drink from the fire hose. So we're here today to talk about AI. So AI, like I said, it's moving fast. So are the security risks that come with it. And whether you're building models, deploying agents, managing processing data, or deploying physical AI in the field, the questions around how do we do it securely and what every organization is wrestling right now, that's what we want to talk about. So in this webinar, Sergi and I are going to talk about, try to cut through all the noise and talk about AI and data security with some real examples and real risks and real recommendations. So, who are we? My name is Chris Howard. I'm the founder and CEO of Softeq. Softeq is been around for nearly 3 decades now. We're full stack, so we do everything from hardware, firmware, mobile, web backend, AI, ML, and data analytics under one roof. And of course, since we understand hardware and we work with all the big semiconductor companies out there, embedded is something that's firmly in our wheelhouse. And obviously, edge AI and physical AI are things that we're really learning into. And I have with me today Sergi Mansilla from Edge Impulse. Sergi, maybe introduce yourself.
Yeah, I'm the director of engineering at Edge Impulse. We were recently acquired by Qualcomm. You might have heard, but basically, what we do is a platform to help you deploy Edge AI on any device, any environment, and we help you go from zero to from no data to having a super performant model that runs on every device and implements AI in the field.
Great. And so let's just get into it. Security questions that people are asking. These are our four main topics. Basically costs, of course. Everyone's concerned about costs. I don't really want to lean into that. Obviously, things cost money. Encryption, super important. Compliance, GDPR, HIPAA, etc. And then data storage. Where does all the training data live? And by the way, we will share these slides afterward. I know several of the slides are text heavy, but I wanted to have that content for you after the webinar. We're just going to touch on a few of the things on each slide. So, Sergio, let's talk about encryption. How is that being
Um,
handled right now with AI?
Encryption, I mean, encryption hasn't changed that much because of AI. If anything, it has become more important, right? Like the encryption in transit and rest are mandatory for anybody that is training or deploying AI. And moreover, there's a lot more data involved than before, right? So before you wanted to secure your data, but now you want to make sure that your training data is secure at rest. And at the same time, with all the prompt engineering, there's a lot of data back and forth as well, potentially with a lot of private data, PAI, and things that shouldn't be able to get out of the loop that you have with your AI. So I think that encryption is mandatory. People are talking about post-quantum encryption, whether it's necessary or not. There are several algorithms that are already guaranteeing post-quantum. I don't think that's necessary yet, but definitely encryption, TLS, as you mentioned in the slide, and at rest are necessary. At Edge Impulse, we use basically the standards TLS 1.3 and SHA-256, I believe, for all our data encrypted at rest.
Okay. So the platform helps you do that.
Yeah,
From
well,
an
you
encryption
can,
standpoint.
yeah, you can rest assured that it's all it's all encrypted at all times. We guarantee that. We have SOC 2, which also guarantees that. But I think that, I mean, I myself, I wouldn't even, not even as a company, but I wouldn't use a service that does not guarantee hard encryption.
Yeah. Yeah, you want to have your data encrypted. That's your secret sauce. That's the recipe to the cookies, right? So,
That's right.
okay, so let's talk a little bit more about security and where it comes to life, right? So, there's a lot of architectural decisions that you have to make especially when you're at the edge, right?
Hmm.
And when you're talking about a real world deployment, you have edge AI, which is what's going on in the hardware, what they say at the edge. For those who don't know the difference, right? You have AI in the cloud. People are familiar with Claude and Edge Impulse platform is something that is specifically designed to run on the hardware itself. So you have sensor data and edge models that are running, in your wearable or your smart device, and then you have data that's also going over the network. And then the third part is, your data lakes, and how you're governing the storage. So talk a little bit about, how you handle that network traffic and that data
Yeah.
lake.
So I mean, yeah, we touched all sides of AI. There's two kinds of ways a device interacts with AI potentially, right? Like one is with already a built model, and the other is the device training the model itself with data. We're getting there, but what we mostly do due to device performance restriction is you create your model in Edge Impulse. You train it, you label the data, everything, you test it, and then when you're happy, you deploy it to your fleet of device or your device if you're just experimenting. So from that moment on, the model is gone, right? Like the device is in the field, you can't touch it anymore. And the model needs to perform. So there's different ways or different security concerns. One, that your training data is not reflecting the real world environment, right? Like it gives the best numbers while you're training it, or while you're experimenting with it. But then once deployed, that chip is not doing what it's supposed to be done to do. Um, and that could be security wise, very bad. The device could make bad decisions and hurt people, even depending on where you're deploying, or feed bad data for a while, which is it's something that you don't want to happen. You don't want to deploy a model on the field for months, use that data to retrain your model. And that data was not good to begin with. The device is not identifying the right things, is not doing the right inference. So there's that level of security. The model in principle is compiled. So yes, it can be hacked, but there's not that much value in that. Your second point of what goes over the network is very interesting because um, it's true that every byte transmitted is a potential attack surface. It's also a potential, energy loss. So you want to be smart about sending only what's necessary when it's necessary. You don't want to be constantly. Let's remember that usually devices out in the field might not have any, or might have a limited battery, right? So everything they do can shorten their lives. So we have to be very smart about when to send and what to send. And before we're talking about encryption. And it's what's interesting in our industry that's happening less and less, but there's still a lot of hardware devices out there where they only support unencrypted protocols to transmit, right? Like they just use HTTP as it is. They don't have a concept of HTTPS, and that's very common in the hardware industry. It's a bit behind on implementing protocols, or especially the more secure protocols. So we found that a lot in the past, in which people deploy industrial devices that transmit via HTTP, and now suddenly it's becoming more pressing by regulation and by ISO standards and so on, that this can happen, right? So people are scrambling because once you have a hardware deploy with a concrete SDK, it's quite a bit of work to change that, to guarantee that it will work out there. And then finally, you mentioned data lakes in your slides. Obviously, once you have your data, this data is very valuable. Arguably, what gives your company the advantage, right? Especially if you have hundreds of devices out in the field relaying data to you. Um, there is no special securing the data lake, whether you have AI or not, but everything becomes more important, right? You need obviously RBAC access, very strong permissions on your team on who can access and what, especially if it's data from a customer. Um, you have to implement everything. Like, let's say you have AWS, you need to secure that data as you would. Now, what is happening, especially on the times of AI, is that new regulations are forcing companies that use models out in the field to keep also the data that your model was trained with, right? If the model causes any trouble down the line, you want to know exactly what trained that model, what data made it may perhaps take the wrong decisions or and such. So that is very interesting because depending on how often you create your model, how often you relabel or you change it, you have to keep a very static copy of the data and the parameters that created that model. So that's a lot of data potentially, and that's a lot of obviously data security that should be taken into consideration.
Hmm. Yeah, I mean, of course, nowadays with the network, right? You've got Bluetooth on these smart devices.
Mm.
Sometimes you have Wi-Fi. Sometimes you have LTE. Sometimes, and now you've got NTN, which is the non-terrestrial network, which allows you to deploy devices out in the middle of nowhere, right? And communicate to something like a Starlink or whatever. But those are a
Yeah,
lot of
yeah.
things that you really keep an eye on, keep safe. But yeah, to your point on like basically repeatability, I mean, I think that's going to be a big challenge because probably most people don't have that right now. Where you have a data lake, the AI made a decision. Later, you want to understand why it made that decision, and some governments are requiring you to be able to repeat that or audit that. And if the data lake's constantly changing, then how do you actually snapshot that, and how often do you snapshot that? It's almost like the data lake has to be a source code repo like we used to have, or still
No,
have,
exactly
right? And
that. Yeah.
yeah,
In fact,
something like that.
yeah. In fact, this is becoming it's quite an issue because nobody has been worrying about. So there's two issues. Like nobody has been thinking about that, having a record of every piece of data created your past models. But we also use a lot of black box models, right? Like when you use ChatGPT as a user today and you use it in a week, the responses are always different. You don't know if the same model was the one that is answering your questions today or internally, right? They give it a version tag, but you don't really know in the future if your models have to be regulated, standardized in any way, or they are in critical decision making. This is already in some regulations and in some ISOs, but that will be the norm. And you have to be able to debug it if something goes wrong, and that requires, as you say, a source code repository of the data and the labels and why these labels were applied to that model, right, or to that
Mm.
data. Sorry. So that's going to be interesting. Nobody is doing it yet. Yeah.
Not really. It's the Wild West. So that's why one day, like you said, you can be Sonnet 4.6. The next day, Fable comes out. The next day, oh, Fable's pulled down. Right. So
Yeah. No. Exactly. Yeah. We're
not so
doing
much on
that.
the
We
edge,
Yeah.
but I mean, it's a similar problem on what we would have for your own data lake, right? How do you version it? Right.
Yeah. I feel like in the edge AI industry, because our models and devices are much more niche and usually they have a concrete industrial or medical application. The edge industry is a bit ahead of this because whoever is implementing that, since the outcome will be critical, they're already thinking about that. We offer data versioning and edge impulse and stuff like this, but I feel like when you go into the big AI LLMs, nobody's thinking about that, and we have AI more and more in more and more critical paths. So this will be a thing for sure.
Mm, okay. So let's talk about some of those risks. I think one of the next one is going to be about this data, but a lot of the risks aren't really what is making the headlines, right? So it can be about the data quality, the model behavior, the access control, and like we've been talking about. Besides the data, there's labeling risk, right?
Hmm.
So, in order to have an AI, the first thing that we have a lot of clients coming to us and they want to implement AI, but the first step in implementing AI is creating the data so that you have something to train the model on, and it has to be
Yeah.
labeled properly in order for the model to be able to figure something out. Um, Vision's a little easier per se because you can, do some things there. But for other cases, how do you detect what you want to detect? And do you have the data collected? And do you have it labeled in the proper way? And a lot of times that takes humans to label it, right? Um, so talk a
Yeah.
little bit about this labeling risk issue.
So this is very interesting. Like for the 7 years that Egyptos has been there, the main problem has not changed. I would say like the technology has evolved. Everybody knows about AI now, but data quality is number one issue. Everybody knows the data has to be good, but when somebody comes and says like, "Hey, I do have all this data. It's good data, but I have not labeled it. I don't have a way to label it." Until very recently, the only way to do it was human effort, and that was hugely expensive. So that was always a problem. Like people had the data, or companies had the data, but they didn't have good labeling. You had to spend a lot of money to label that data. Now, Gen AI is here, and we actually offer Gen AI labeling of your data. Um, and the risk, so here's where you, as a company, need a risk assessment of the kind of model that you're training. Gen AI is extremely useful at labeling your data, but there are two things that it can do mistakes. Obviously, it can make mistakes on labeling the wrong thing. So you have to be comfortable with that fact. And if you're deploying a high risk model, maybe you shouldn't be comfortable with that. The other one is the black box nature of commercial Gen AI models. You don't know what's the bias of the model or how this data has been inferred to, or how this label is the right label for the data for the image you're presenting. Let's say, and this is important because of what we were just talking about. Regulations. If you need to explain why your model behaves like it does, you have to explain why the images were labeled that way. If you're using, for example, a black box model, you won't be able to do that. So that's an interesting thing, and a way there people find ways to at least guarantee better accuracy for labeling. Take a small sample set, run some computer vision algorithms that guarantee that, if you're detecting hard hats in a factory, there's a hard hat in this image, and it's been signaled properly. So you can then test a small sample of images, see if the labels kind of make sense, and then extrapolate
After you've
to all your
after
images.
you've applied the generative AI, because of
That
course people say, well, this is very manual intensive human process, so why don't we use AI to actually generate the data so that the AI then can figure out, something from the model. But if the AI isn't really providing good data, it's hallucinating, it's labeling incorrectly, you're going to get garbage in, garbage out. So what you're saying is once you've implemented maybe a Gen AI model or something that like tries to look at all of your data, pick a small sample set, and then basically review that to make sure that the right decisions were being made by the AI, right?
Yeah, and it's one of the areas that you should really agonize over the prompt you use. If you're going to use Gen AI to label 100,000 images properly, the prompt matters a lot, because the AI will take it literally. So I think that what's interesting here is that then sometimes you have to think about what model to use to label it. And we have very powerful LM models like nowadays, but sometimes perhaps a small model that is more focused on your area of expertise would be better. Some model that has been trained on a smaller subset of images that are more related to your field. Let's say like a model that has been trained on industrial settings would do potentially better than the latest ChatGPT at keeping their context narrow. So sometimes the solution is not used like Gen AI, but just your own model to label, like another model to label your future model, right? If that makes sense.
Summaries of your day and what it saw and things like that. And I remember when it first rolled out, I was like, wow, it's telling me there's a raccoon in my driveway. And I'm like, I got to see this raccoon. And then you look and it's a cat, but I mean, there are some
Close
limitations,
enough.
but for some reason it's focused on raccoons. I don't know why.
Maybe
The
trained
likelihood
in
of,
a place where it's full of raccoons,
yeah,
just like
yeah, it's
right
trained
in
in
your
the
trash.
Seattle area where there's more raccoons. I don't know, or wherever Google trained the data, but yeah, it's a
Yeah,
good
there's a
point.
lot of instances of that. In fact, some of the most popular models out there, like MobileNet and so on, they have an insanely huge image sample. They've been trained on a lot of images, but that doesn't necessarily mean that, if you have a very narrow kind of image you want to identify, that wouldn't one necessarily work well for you.
Well, I think that's really what also can happen at the edge, like you said. You want to have a smaller sampler size. You don't need to detect raccoons. You don't need to detect the whatever the 200,000 mammals in the universe, but you're only interested maybe in a dog and a cat detection, right? And those are going to be the ones that show up in your images and video the most. Or whatever your application is. So, and
Hmm.
then that's why those LLMs can actually exist. Those models can actually exist in the smaller capacity of a dog collar or a wearable or an IoT device or something like that.
Hmm.
So, like we were talking about security issues and data, right? And what's going into the model affects your security and its output accuracy. I think we talked a lot about this. I mean, one is having too much data, right?
Hmm.
Overloading the model with a bunch of stuff that really doesn't matter. Another one is not having enough data. We've also seen that because, of course, if you don't have your data lake and you want to have your data and you want to generate it and you want to label it and it is intensive, you end up with like, oh, well, we only have a few hours of data here that we need to train the model on. And guess what? It's not going to be that good
Yeah.
at detecting what you want to have detected, right? Have you seen that as well?
Yeah, I mean, I think that this is the root of all, or one of the root of all problems with custom AI models, right? Or too much data. Organizations often think um, more data is always better. In reality, flooding a training pipeline with unvetted sensor telemetry data increases exposure, compliance exposure, and creates more surface area for leakage, more often PII or proprietary metrics, industrial metrics even. Um, so yeah, and too little wrong data or domain irrelevant data degrades reliability in high stakes fields. Like let's say you have AI in devices in energy grids or industrial equipment. Um, a model that generates confident but entirely wrong predictions is not. Is not
Can
just
be
a,
a
like
safe.
a mistake, but it can be really, really bad, right? And it's a security hazard. Um, so yeah, this is pretty common. We work with customers to understand their use case. It always depends on your use case, right? Like depending on the scale and the complexity that you're deploying the final model, you need a risk assessment. Um, if you and the missing data, yeah, exactly. What we were talking about or related. If you cannot reconstruct the data stack, the pre-processing steps or software versions used for a specific training run, then you can't reproduce or audit model. So before we spoke about the data versioning, but there's more than that. Like what software versions did you use to create this model? What was involved in every step, right? And again, most people nowadays they're like, I don't know, it works fine for me. But the question is like, where are you going to deploy that? This is going to manage the energy grid. In that case, you need a static a static metadata of everything that has been involved in creating that model, so that you can not only analyze it but also reproduce it and see where that model gets why that model is inferring what it's inferring.
And probably also utilizing something like video to film, if it makes sense, like what decisions were being made for a specific device, so you can go back and see why it made that decision. You've got, okay, of course, a self-driving car is a very big, complicated system, but it definitely needs to detect when a light is green and when a light is red. But if it makes the wrong decision, and you go back and you can look at the video and see that, wow, the light was red with
Yeah.
a green arrow, so it's like, and so now you've got something else. You need to try to label a new situation that, what do you do when you've got both lights on the screen, or a yellow light, for example, right? But
Yeah,
on an edge
and
device, it's the same, right?
what we use a lot, or our customers use a lot, is synthetic data. There are framework, and in fact, you can use Gen AI for that, right? So if you have situations like, let's say you're training a red light, green light detector, but obviously the time of the day, the lighting, everything influences this, and you might not have video samples or photo samples for every possible situation. So then you can always analyze and understand your data, and then generate from your existing data, generate new situations, new images that match the scenarios you want the AI to react. Again, applying common sense and checking that the Gen AI is doing the right thing. But this is pretty common, not only on images, but also audio and sensor signals. Like sometimes you don't have enough data to train your model. And that's not your fault. It's just simply there isn't there. Or you want to create a new model and you haven't explored the field. So you can use synthetic data to create that.
How do you know if you have enough data? I mean, how much data do you think models typically need in order to be trained? I know there's a wide range of models, so just kind of
Some of
like,
my colleagues will answer this better. Usually, the more data, more relevant data, the better. But there's confidence levels, and we provide plenty of metrics that will tell you, like, in given a set of test data that should reflect the real world, how successful your model will be out in the field. But yeah, not the more data, but the more relevant data and the more samples of the scenarios that this model will find, the better. That's always like this. The more training data, the better. Now, again, it depends on the situation. If it's the more concrete, or the more, let's say, an image is, the more contrast you have, or for example, if you have, what we do a lot is anomaly detection as well. So um, for a conveyor belt in which the camera will be looking down, and the surface, it will always look the same. Like, there's no much variation, there's no random lighting or anything. If you have a controlled environment, that makes it much easier. And we've trained very successful models with as little as 50 images by using anomaly detection. So in this case, you train the model in a different way. Instead of telling the model, these are all the scenarios you could find, we tell it, these are the correct scenarios. Anything that doesn't look like this, you flag it as wrong, or so it's, instead of detecting the normalcy, it detects the anomaly, and then you can go down on data for training models like quite a bit. But it depends on the situation that you're handling. Like, the more control environment you can have, and in the industrial setting, it's pretty common to have some power over your environment. That's better for Tesla driving
yeah.
decision making. That's extremely hard because everything
No, but
is
it's a good
changing all the
point. I
time.
mean, I think that's a good point, is to train on the anomalies, and basically the edge conditions, and not the normal conditions, right? So these are the things we want to detect. Make sure we have enough of these cases. If you don't see this kind of thing, then ignore everything else. So I think that's a good point. Let's talk briefly about agentic AI. I think this is a problem on any AI, right? I mean, we've seen a lot of stories out there where the AI is out there, um, deleting code and repositories and bank accounts and whatever else. But my dad used to say, back in the 70s and 80s, right? The computers were high-speed idiots, right? And I think that's still true, but they're also very, they're kind of like even higher speed. And people, that I think what's different is that people forget that they're idiots. They think they're super smart, so they think like an AI agent is like getting a lead engineer in there, and that on day one you should give them the keys to the kingdom. Where the reality is, most of the time they're more like a junior, and you certainly wouldn't give a junior, rewrite delete access to your GitHub, and you shouldn't do that for AI either, right? So just to highlight for those listening, make sure you've got minimum permissions. That's standard practice, no matter what employee you have, right? I don't give every employee that joins Softeq the login access to my bank account, right? And then auditing the API surfaces, right? And then basically speed without judgment. That's basically that high speed doing things, and then you point it out to the AI and say, oh yeah, you're right, I shouldn't have done that. Yeah, well, it's kind of too late now. But this isn't exactly, I mean, it's security as well. I mean, because, if you are using AI, you're going to dig into AI agents. You want to make sure you put some guardrails around these guys, because they will do a lot of things very fast, but they can also get way off the path and create a lot of chaos. So.
Yeah, I think that the worst, and I think that it's a disservice to junior engineers, because I think that junior engineers rarely sound as confident as agents do, right? Like, so an agent is always like, absolutely, this is gonna go ahead and do that. I don't think anybody has I mean, your points are excellent, but I don't think anybody yet has an idea of exactly how to control this. On the one hand, the illusion of productivity is huge, and the productivity, honestly, I mean, it does amend productivity, but um, I think that there are too many too many issues with using a lot of agents to build software that we're still figuring out how to leverage. Like, obviously,
Yeah.
the tool is, and the tech is good, but giving an autonomous agent blanket system access is obviously immediate security failure. These agents are trained on so much data, and these LLMs are so powerful, but that you can't guarantee the outcome every time. So you need very, very strong guardrails, and you need old school software guardrails as well, like role-based access controls, RBAC, access management, things that an agent cannot get their way around, because they will. I see it. I still manage to code every now and then, and the agents tries um, to fool me in the way they solve problems, right? Like, you would tell, like, oh, can you make this dependency? Can you use an R dependency or something? And we'll go ahead and remove files and tell you, like, all right, that's not a problem anymore, because we
I
don't have
deleted
that
it.
functional. Yeah, I deleted it, but now you don't have
Yeah.
whatever functionality you had. So um, anyway, I think that if you're going to use it or provide access to your platform for agents, you need to audit every API surface. You need to have a very clear map of your API surface, whether you use OpenAPI or one of those tools, so that you have a guaranteed schema of your APIs that you're exposing at every point, at every step, and secured accordingly, every endpoint. Um, so basically, treat agent integration as highly privileged access management. So
Yeah.
yeah, log everything the agent requests, so you can deconstruct it, the payload it sends, and the system response.
So you can continue
Yeah,
to
yeah,
tweak, right? When
yeah,
you update
exactly, yeah.
files, etc. And hey, I love juniors. By the way, I've had some of the smartest guys. I was a junior at IBM and NASA, so I have a soft spot for in my heart for juniors. I've hired a lot of juniors over the years at Softeq, and proud to say a lot of them are working at even the top companies now after learning the ropes at Softeq. But yeah, you just have to make sure you're supervising,
Yeah,
essentially.
no, no, absolutely. And yeah, the speed with that judgment point is interesting. I think that, and what you said
Yeah.
about your dad, right? Like, it's true. A junior will fail slowly, but a machine fails in a microsecond. So before you realize, it's all gone, and that confidence might make you miss it for a while
Mhm.
until you see
Yeah.
what actually happened.
Yeah.
Um, yeah.
So let's talk about a few more risks here. Yeah, obviously there's some regional hardware compliance issues if you are going to, operate, globally. For example, differences between how the U.S. and the EU and APAC treat
Mhm.
requirements. Supply chain attacks. Maybe talk a little bit about that. What does that mean exactly?
Yeah, a supply chain attack, it's actually one of the points more important for me right now. Supply chain attacks is when one of your libraries or dependencies in your software gets replaced or injected with some malicious intent and software, right? So you're depending on um, on some software package, and then some. It happens pretty often lately on npm for the ones who use Node or Python pip. A package is hijacked and you're using that package in your stack. So when you run it or when you use it, it will try things in either your engineer's computer, your central servers, etc. And this has always existed, but you might have heard of the latest LLM models like Mythos and these others. They're becoming extremely good at finding security problems and security holes. And obviously, this is being used for hijacking open source software that everybody depends on, package management, schemas, and stuff like this. So, in the last, I would say, 6 months, we've had a wave of supply chain attacks in which popular software gets, including the Linux kernel, right? Like Linux kernel had more vulnerabilities than ever before because AI is being used to detect those. And it's relatively easy to inject this on every package. We found that we haven't had vulnerability problems, but we found that dependencies that we are using have been hijacked there. We avoided it because we're pretty radical in how we use dependencies. Basically, we pin everything. By pinning is means that once we verify that a software dependency is working for us, we keep that version. Some people call it vendoring. We pin it to that exact version, so it will never download an update to that dependency. Right? This is a common practice, but not common enough so that it cancels the problems in the industry with this. So my advice there is to be very strict with what dependencies you keep, with what version of dependencies. There are mechanisms in package managers that allow you to never update a dependency with a version that isn't older than, let's say, 7 days or 2 weeks, right? So
Mm.
that you at least breach the moment in which people realize that the dependency is causing trouble or so on. So
Right, the
there's
zero day attacks, basically. So
exactly
you can,
zero day attacks, yeah, which
and
is the
then
main problem with that.
don't you guys generate all the code like basically like a hard coded, version of the model?
Well, for this is yeah, I mean this could basically, yes, we generate codes at the times, but basically the model that gets generated could be injected with malicious intent by one of the dependencies. So if you control the dependencies and you have a grasp on the software that is involved in generating your model,
Mhm.
the model should be okay. But that's easier said than done. Our stack, I don't know how many dependencies we have, but there are thousands. So on top of best practices, every code platform, there's a lot of security companies out there. We use a lot of the GitHub provided security analytics, which they continuously scan your dependencies for vulnerabilities. There's a lot of the software. I think AWS offers others. I would definitely, unless you have a security team that is looking at that, to have those scanning tools for detecting zero day exploits are essential nowadays. They're just coming much more often and much faster than before.
Mhm. Okay. I mean, there's some other things on here like prompt injection and, of course, keeping data away from AI actions. You don't want to kind of mix in your training data, for example, that can cause problems. And we talked about the speed before. There's both
Hmm.
the speed of the AI, there's the speed of the threat landscape. People are using AI in order to figure out these threats. So that's actually, something you need to keep an eye on. And then, of course, documentation debt. We talked a little bit about that. How do you make sure you're documenting your software stack and your AI framework versions, your training data, all that should be somehow version control, but that's, I think, something that needs a lot of work for most people. I do want to get to some of the recommendations. So let's go ahead and talk about that. So
Yeah.
you know, I'll let you talk. Go ahead.
Oh, no, no, sorry. Yeah, I was gonna say let's get into it, but
Yeah.
um, yeah, that's certainly a thing that from what you previously said, I think that the speed of at which AI is happening is a big problem for companies because it feels like if you're not using it, you're gonna be outcompeted, and that
Yeah.
causes for companies to drop a lot of, um, of security rational processes. And I think
Moving
that
too
one,
fast. Yeah.
yeah, moving too fast, allowing people to use different tools. Like I don't know what I think it was Meta that had like a scoreboard of who used more tokens. So that's a bit of a dangerous games if you don't have rules of thumbs. Like you outline a couple here. Recognized frameworks are a good one. NIST is a really good framework, but so is OWASP and the top 10. I think that, and if your company complies with, let's say, SOC 2 or this kind of security compliance measures, I think that that's the first step. Like it's a rule of thumb. Like if you, it's a way to say like if I comply with this, I'm relatively safe. And and if you're not complying with it yet, it's quite an effort. So it's not nothing. It's like the basis in which you will build the rest. If you don't have an adopted framework or compliance or anything like this, it will be much harder to just cherry pick what security measures you want to implement in your company.
Yeah. Yeah, and then of course we talked about the human AI review loop. So we went into that. Basically, make sure you're double checking what the AI is recommending, and you get your model right. Number three, I see a lot also as well. People expect AI to do things securely, but it doesn't. You can do vibe coding, you can do model creation, you can do a lot with AI, but unless you actually tell it to pay attention to security and in the way that you want it to pay attention to security, it's go ahead. The doors can be wide open, right? It's like build me a
Yeah.
barn. Well, the barn is wide open. Nobody's saying, "Oh, you didn't tell me to put a lock on the door. You didn't say you didn't want the cows to get out," right? So
Yeah, exactly. I
um,
think that yeah, it's what is useful. I mean, using AI to secure your environment alone is not, as you say, like it will give you a different inputs depending on the prompt and what the access to the code that it has. We find that it's relatively useful at identifying security problems once you've built your code and your platform. Right? It's a good security reviewer for code, for example. But when you build a platform, is not as useful at adopting security measures or at being secure by default because it's being trained on the code out there, right? And the code out there is not always safe. I think it's about prompting it nicely and more using it more as a reviewer than as a creator. If you use it as a creator, be sure to add the reviewing stage continuously. As well, and create non-AI guardrails. I think that's a good advice. Access to things, like basically good old tests that check for concrete parameters once your software is deployed. I think these go a long way at keeping AI at bay when it's
mm,
deployed.
okay. Yeah, and then of course, accelerating with existing tooling, right? I mean, there's a lot of platforms out there that can assist with responsible deployment, like Truffle Hog and GitGuardian
Hmm.
and others. So pay attention to that. And if you don't know what those things are, then get someone on your team that does, or a partner. So what's coming next in AI security, right? So a couple of highlights here. Federated learning at scale, which is training models across distributed devices, is one option. Hardware rooted trust, automated model auditing, regulatory convergence. Anything you want to highlight here that stands out to you?
No,
We'd love to
these
watch.
are all interesting. I think yeah, federated learning at scale. Traditionally, edge AI requires centralizing massive amounts of sensor data or user data in the cloud to train a model. Federated learning it's an easy concept. It basically flips this by training models directly across many distributed edge devices
Yeah.
without the raw data leaving the device. But the advantage with this is that now if you have 10,000 devices out in the field, instead of all sending data and you training it with the costs and security risks that it involves, they can generate the model on their own with existing training data they have, right? So the raw data does not leave the device. That reduces the enterprise data transit risk, and you're moving the compute to the data rather than the data to the compute. So it eliminates a massive cloud target vector. It's we are not seeing it yet deployed to in the field in significant numbers, but it definitely coming with more capable devices and more powerful NPUs and so on. So that will be very interesting.
Yeah.
Um, yeah,
And
the
then, yeah,
hardware root. Yeah,
as
sorry.
yeah, no, I mean, we don't necessarily have to go through every one of these since we're fairly long on time here. But obviously, if anybody has more questions about some of these developments, then reach out to myself or Sergi about it. We only have another slide or two left here. Some of the emerging threats to watch out for, right? So some of the ones that I highlighted here: model theft via inference, right? Some of these are more and more complicated because as AI matures, so does the threat actors, right? Adversarial inputs at the edge, right? Physical world attacks designed to fool, right? The model.
Yeah.
So once the threat actor understands how the model works and how the logic works, then it can start to fool how its decision making, works. There was a story I read recently, and because everything was being surveilled, they put like almost like a QR code. There was a thing they could wear on their forehead, like a QR code that would actually distract the AI from doing its facial recognition. It would kind of go down into like a black hole of trying to figure
Mm.
out what that was. So I'm sure there's going to be things like that that are trying to essentially change for
Yeah, I
example, like
think
how a
yeah.
car reacts in order to cause an accident because it knows it stuff that doesn't happen in the real world, but now the car doesn't know how to react to it, right? Or whatever the device or wearable is.
Yeah, I think that if we take away that in a few years all devices out there will have some AI component, everything related to data poisoning, and agentic chain exploits and stuff like this, it becomes much more scary, right? If edge systems become more autonomous, they rely on several step workflows. If an attacker manages to inject malicious data or compromises a third party, let's say retrieval augmented generation pipeline feeding into an asset, they create an attack surface at that point. And depending on where that surface happens, it could be a disaster, right? So I think that there's attacks that we can't even envision yet because there's not that much AI reliance on the physical world, but it's happening.
Yeah. And this is, the highlight here is just the gap between the AI deployment and the security team readiness. It just keeps getting wider. And so
Mm.
things have to catch up a little bit. And then I think, we need to address the fact that, we're going to have to keep these devices updated as these threat actors, get smarter and smarter, just like Windows Update, right? In the past, every time somebody comes out with some exploit, we have to make sure these devices are updatable in the field. Let's talk a little bit about key takeaways, and then we'll get to our Q&A. Doesn't look like we do have a couple questions, so that's good. So just to summarize, Sergi, what we talked about, basically data, right? Know what goes in. So that data quality, the labeling, the input scope, the security decisions, that's super important, which is all happening before you actually get to the inference, right? Minimizing your surface, talked about that. Anywhere you can restrict, access, minimum required permissions, default, least privilege everywhere for humans and AI systems. They both apply. Keeping the human in the loop. We need to have that supervision of what the AI is doing, so that like we said, the AI does not review its own risk, right? So and then building for the future, right? So as that threat landscape continues to evolve, we need to make sure we can respond to that as more and more data becomes available on what the threat actors are doing. So those are all things that we can all do to and prevent some of this disaster scenarios, so that we don't get enslaved by our overlords at some point, right? Yeah. So shameless plug for my podcast. I've been talking about AI a lot lately. Had NVIDIA on recently. He was the former CTO for Stephen Hawking, talking about how to use AI for good. Just had Microchip on the podcast, talking about AI eras. I had Edge Impulse, Brandon, on the podcast at CES. If you want to, hear more from Edge Impulse, there's an episode with Brandon. You go about 130 episodes so far, so there's probably something there for everyone. And also feel free to reach out to either Edge Impulse or Softeq with your questions. Sergi's LinkedIn is here. Feel free to connect. Mine as well. And again, the Forward in the Future podcast. Let's see what questions we have, and then we'll see what we can probably wrap up here in a few minutes. So let's do first one. How do you see your clients balancing edge AI capabilities versus cloud AI to optimize data transfer and maximize data security? So that's a good one. It's like basically, what are you doing locally? What are you doing in the cloud, right?
That's a super good question. And the disappointing answer is it depends so heavily on what you're deploying, right? But what we're seeing is there's more like hardware devices out in the field have gone in the last years since I am in Edge Impulse. We were basically catering to MCUs and small devices that did optimize but very lightweight inference to absolute beasts that we're seeing nowadays, like Qualcomm devices as of late. So it depends. Ideally, you don't transmit data, but you need to transmit it somehow at some point. And the decision is, do you accumulate data on the device and wait to transfer it? Do you do some kind of you accumulate data on the device and then you process it so that you send less data because you already filtered it, or you do, we're just talking about federated learning, which is a possibility that will come at some point. It also depends, like, is your device connected to the electrical grid, or is your device on the African savannah, which we had a customer that had it to detect animals roaming by. In that case, you don't have the luxury of infinite energy, and your device has to survive for 6 months at a time without energy. Then you can accumulate data, or you could exploit something like LoRaWAN. You could have a gateway, which is a device with connectivity, and then all the other devices out there don't have it. But every 100 meters, you have Chris was talking about Bluetooth before, any kind of communication. So it depends on your setup. But the universal rule keeps being the same. Like, don't send data that you don't need. So any signal processing and any post processing you can do on the sensor data that comes to your device is ideal. Like, anything you can remove or even not acquire in the first place, right? If your device has enough of, let's say a microphone, does it always have to be on? Does it have to be continuously querying data and parsing that data, or can it just take samples? It depends entirely on your use case. But what we're seeing, like the trend is devices are starting to do more. When I started with Edge Impulse, for example, the idea of putting an LLM on a device, it was a nice thought experiment. Somebody did it, but it was not useful at all. They were not powerful enough to run LLMs. Now it's a thing. Now we run VLMs on device, and they can do their own inference. So things are changing towards making the device do more
Which
inside,
keeps
and
the
then
data more secure, right? Because you're doing it
exactly,
on
yeah,
the device. Used to be like you said. I mean, the LLM or the machine learning on the device would be like detecting a wake word, right? Like Alexa,
yeah,
and then it would like record the data and send it up the cloud and back down again. But now, there's more and more that's done locally, and you don't actually have to go to the cloud
yeah.
to get your answers. That does increase security. Last thing, so we wrap it up here. That we're coming up on the 1 hour mark, and this is an easy one. This is great information. Would you mind sending a copy of the meeting? Yes, everyone that registered, you have two things. The recording of this webinar is immediately available at the same link that you used to join, so you can watch it again or back up to certain parts. And then second thing, we will send a copy of the deck to everyone that registered for the webinar. All right, with that, thank you all for sticking with us for an hour here. Sergi, thank you very much for all of your insights. I appreciate you taking time out of your busy day and on the
Thank
other
you for
side of the
having me.
planet, I think, in the evening. And really appreciate it. All right, thank
Likewise.
you. Thanks for joining, everyone.